Hi everyone, welcome back to another Math Basics video, this time on exponent laws, and then some examples on working with exponents. When you see this sort of expression, the base tells you the number that is going to be multiplied repeatedly, and the exponent tells you by how many times. So for this example, we have 2 to the power of 4. So that means we are multiplying the number 2 4 times. So 2 times 2 is 4, times another 2 is 8, times another 2 is 16. And that is how we get our answer. So the first exponent law I want to talk to you guys about is called the identity exponent law. And that law basically tells us that any number to the power of 1 is equal to that base number. So in this expression, we're just using a to represent any base number. So for this example, we have 2 to the power of 1, and that just equals our base number 2. And that is true for any base number, including negative base numbers. The next exponent law I'd like to tell you guys about is the product exponent law. And this law states that when you multiply two numbers that have the same base, you can add their exponents. In this example, we have 2 to the power of 3 times 2 to the power of 2. Both of these numbers that we're multiplying have the same base of 2, so that means we're able to add the exponents, giving us 2 to the power of 5. And when solved, we get 32 as our answer. I also show this down below as 2 to the power of 3 is the same thing as 2 times 2 times 2. And 2 to the power of 2 is the same thing as 2 times 2. So multiplying those two things together, we get 2 multiplied by itself 5 times, or 2 to the power of 5. The next exponent law I'd like to talk to you guys about is the Quotient Exponent Law. This law says that when you divide two numbers with the same base, you can subtract the exponents. In this example, we have 2 to the power of 3 divided by 2 to the power of 2. This is the same thing as 2 to the power of 3 minus 2. We do the exponent in the numerator minus the exponent in the denominator. That gives us 2 to the power of 1, or in other words, 2 as our answer. We can also show this in another way, as 2 to the power of 3 is the same thing as 2 times 2 times 2. And 2 to the power of 2 is the same thing as 2 times 2. Since two pairs of 2 in the numerator and the denominator cancel out, we are left with a 2 in the numerator, which is the same thing as our final answer, 2. The next exponent law I'd like to talk to you guys about is the zero exponent law, which states any number to the power of 0 is equal to 1. In this example, we have 2 to the power of 0, and that is equal to 1. But we can explain this another way. 2 to the power of 0 is the same thing as 2 to the power of 3 minus 3, for example, which can be rewritten using the quotient exponent law as 2 to the power of 3 divided by 2 to the power of 3, which can also be rewritten as 2 times 2 times 2 divided by 2 times 2 times 2. And since three pairs of 2's in the numerator and denominator can cancel out with each other, we are left with 1 as our answer. So that's just a helpful way to understand why any number to the power of 0 equals 1. The next exponent law I'd like to talk to you guys about is the negative power law. This law states that any number to the power of a negative exponent is equal to 1 divided by that same number to the positive version of that exponent. So for example, we have 2 to the power of negative 3. That is the same thing as 1 divided by 2 to the power of positive 3. And when we solve, we get 1 over 8. We can also understand the negative power law using the quotient power law. 2 to the negative 3 can be rewritten as 2 to the power of 1 divided by 2 to the power of 4. since 2 to the power of 1 minus 4 is 2 to the negative 3. This can be rewritten as 2 divided by 2 times 2 times 2 times 2. 1 2 in the numerator can cancel out with 1 2 in the denominator, and we're left with 1 over 2 to the power of 3. The next exponent law is quite simple. It's the power of a power law. This law says if you have an exponent to the power of another exponent, you can multiply the exponents. So for example, we have 2 to the power of 2, and all of that is to the power of 3. That is the same thing as 2 to the power of 2 times 3, which is the same thing as 2 to the power of 6, and when you solve, gives us 64. Another way we can explain this is using the product exponent law. Since 2 to the power of 2 to the power of 3 just means that we have to multiply this number by itself 3 times. And since the product exponent law states that when we have the same base, we can add exponents, we end up with 2 to the power of 2 plus 2 plus 2, which also gives us 2 to the 6. The next exponent law I'd like to talk to you guys about is the power of a product law. This law states that when you have a product, so two numbers being multiplied together, to some power, you can apply the power to each number being multiplied together in the product separately. So for example, we have 2 times 3 to the power of 2. That would be the same thing as applying this 2 to each of these numbers separately, giving us 2 to the power of 2 times 3 to the power of 2, which gives us 36 as our answer. Another way we can explain this is by rewriting this expression as 2 times 3 times another 2 times 3. And when we rearrange these numbers, we end up with 2 times 2 and 3 times 3, which we're able to rewrite as 2 to the power of 2 times 3 to the power of 2, giving us the same answer. And the last exponent law I'd like to talk about before we dive into some examples is the power of a quotient law. This law states that when we have some fraction raised to a power, we can apply that power to the numerator and to the denominator separately. For example, we have 2 over 3 to the power of 3. That is the same thing as writing 2 to the power of 3 divided by 3 to the power of 3. And when we solve, we get 8 over 27. We can explain this by rewriting this expression here as 2 over 3 multiplied by itself 3 times. And as we know, when we multiply fractions, you multiply the numerators together and the denominators together. So we get 2 times 2 times 2 divided by 3 times 3 times 3, which gives us the same answer. For our first example, we have 6 to the power of 3 times 6 times 6 to the power of 2. To solve this, we can use our product exponent law. Since we have the same base, we can just add the exponents. So that's going to be 3 plus 1 plus 2, which gives us a total of 6. So for our answer, we get 6 to the power of 6. Our second example also uses the product exponent law. We have the same base of -2 in both of these terms. So all we have to do is add the exponents. So 5 plus 4 is 9. So our answer is -2 to the power of 9. For our next example, we are also multiplying numbers with the same base. So we can also use our product exponent law. So this gives us 2 over 5 to the power of 5. But we can simplify this further using our power of a quotient law, which tells us this is equal to 2 to the 5 divided by 5 to the power of 5, which is equal to 32 divided by 3,125. For our next question, we have the same base, but we're dividing exponents. So this uses our quotient exponent law, which states that we can just subtract the exponents. So this is equal to 9 to the 6 minus 3, or 9 to the 3, which is equal to 729. For our next question, we have some division and also some multiplication. So let's just do it step by step. Since these have the same base, we can just add the exponents. So that's going to be equal to 4 to the power of 5 divided by 4 to the 5. Since our numerator is the same as our denominator, that means our answer is going to be 1. For our next question, we have 2 to the power of 2 divided by 2 to the power of 11. So that is going to be equal to 2 to the power of 2 minus 11, or 2 to the power of negative 9. But in math, we typically don't like to write things to the power of a negative exponent and prefer to express it as a fraction. So using our negative exponent law, we would prefer to write this as 1 divided by 2 to the power of 9. I'm going to show you another way to solve these that helps me out sometimes. To make things so that we don't have negative exponents, I like to follow this rule. The smaller exponent always travels to the side of the larger exponent, and when it crosses the line, it changes the exponent's sign. I like that because it rhymes. So I would rewrite this expression as 1 divided by 2 to the 11 times 2 to the power of negative 2. And then using our product law, I would add the exponents, giving us 2 to the power of 9. And that's how I would solve something like that. You'll see why this is useful later. This next example has a power to another power. So this uses the power of a power exponent law. So all we have to do is multiply the exponents together, which gives us 5 to the power of negative 8. But if you remember, we don't like to write things to the power of a negative exponent. So I'm going to rewrite this as 1 divided by 5 to the power of positive 8. This next example has a variable, but don't be alarmed, the rules still apply the same. Right here we have a product. We have 8 times our variable x, and all of this is to the power of 2. So we can use our power of a product exponent law, where this power gets applied to both the 8 and the x individually. So we can rewrite this as 8 to the power of 2 times x to the power of 2. And 8 to the power of 2 is just 8 times 8, which is 64. So we get 64x squared. For question 9, we have 3 things being multiplied together, but they all have the same base. So we can just add the exponents. So we end up with y to the power of 4 plus 2 plus 5, which gives us 11. So our answer is y to the power of 11. For question 10, we have this confusing mess, but don't be scared, we're going to take it step by step. So the first thing you can do is multiply the terms in the numerator. Remember, if they have the same base, you can add exponents when multiplying. So since these two both have the same base, we can add their exponents. So that's going to be equal to a to the 2 plus 3. And these are both b's, so they have the same base, so we can also add their exponents. So that's going to be b to the 2 plus 1. And this is all going to be divided by a to the negative 1 and b to the positive 6. So we end up with a to the 5 times b to the 3 divided by a to the negative 1 times b to the 6. This is where my trick comes in handy. Remember, if they have the same base, the one with the smaller exponent travels to the side of the one with the larger exponent. And remember, when they cross the line, the exponent changes its sign. So this a to the negative 1 would change to a to the positive 1. And this b to the 3 would change to a b to the negative 3. Giving us this new expression. Now all we have to do is add our exponents. And as you can see, our answer is already in a form where all the exponents are positive. For our next example, let's apply our power of a power rule to both this bracket and this bracket. So for that, we get 3 to the power of 3 times x to the power of 3 times y to the power of 2 times 3, or 6. All of that times negative 4x squared times y. All of this is divided by 2 to the power of 2, which is 4, x squared to the power of 2, which is x to the 4, and y squared to the power of 2, which is y to the 2 times 2, which is also 4. In the next line, we can cross out some terms and simplify. So 3 to the power of 3 is the same thing as 27. This negative 4 can also be rewritten as negative 1 times positive 4. So if we think about it like that, we can cancel out the 4 in the numerator with the 4 in the denominator and keep this negative sign here to represent that we have negative 1 times this remaining portion. This is the same thing as x times x times x. And this is the same thing as x times x times x times x. So 3 of these x's would cancel out with 3 of these x's, leaving us with 1 x at the bottom. So this allows us to cancel out this x cubed at the top and rewrite this as just x, or x to the 1 at the bottom. And one of these x's is able to cancel out with this remaining x at the bottom. So we can cancel this one out and rewrite this one as just x to the 1, or just x. And now we have no more x's, so we can rewrite in our next line just an x at the top to represent this remaining x. We can do the same thing with our y's. 4 of the y's at the bottom will cancel out with 4 of the y's at the top, leaving us with y squared. Now we can just multiply our remaining y's in the numerator. So we just have y squared times y to the 1, or y cubed. Now don't forget about this negative sign in the numerator, so that makes our answer negative, giving us our final answer of negative 27 times x times y cubed. Now for one last question. Let's get rid of this power outside of the bracket by using our power of a power rule. So that would give us 30g squared h times 4g squared h squared, because we apply this 2 to each of these terms here, all divided by 5gh squared times 6gh. 30 is the same thing as 6 times 5, so it cancels out with the 6 and the 5 in the denominator. There are 2 g's in the denominator, so it will cancel out with 2 g's in the numerator. And there are 3 h's in the denominator, so that will cancel out with 3 h's in the numerator. So all that we're left with is 4 times g squared in the numerator. So our answer is just 4g squared. Once again, I'd like to thank you guys so much for watching. Please leave any questions or comments down below, and I'll see you in the next video.